All right. I have a few tricks to debug CTFE code, and one of the tricks to debug CTFE code is to build your own error stream, which you can then return as a string. If you have this code, this should just work with the two functions. When I compile it, it doesn't. Okay, that's not great. It has to be static assert when it's used out of here, but yeah. But now it should when I add the semicolon. This works. If I do it with the wrong value, I don't want a micro break now. It will give me a static assert. I cannot deal with this, and it gives me the value that it cannot deal with. And when I now want to do the same thing with a float instead of an int, something surprising will happen, or maybe something that's not so surprising. So now I enable the other function. And instead of the thing I want to get, I get an uncaught CTFE exception, and it tells me it can't convert floating point values. Now, I have a compiler backend, a complete compiler backend that works fully at CTFE and supports floating point. So how do I get these error messages out? Well, there is an easy solution to that. I import a module that I wrote. It's called CTFE FPConf. And instead of toString, I have to say CTFE D2A. No, FPConf D2A. I always make that mistake, and I never played Dota. And I can't do that. I have to import the current directory, and I get an unrecognized. Yeah, that's probably what happened. What? Maybe I changed the module name. Anyone see what it is? Yeah, it's wrong. Has to be underscore CTFE. We do that. No, don't. This is what happens when you don't look at the keyboard while typing. If you're not used to that crappy laptop keyboard. And now it tells me static assert, I cannot deal with this. And it gives me the 1, right? When you use printf, it would give you 1.90, whatever. But this thing can correctly give you the floating point values that you actually pass in. If I say 2.3.3, and of course here I have to say the same. I remove the parentheses where? Which one? Oh yeah, yeah, X. Not another microbit. And it tells me this also correctly, and this is pretty cool. We can now print floating point numbers at compile time. What is your reaction to that? Do I have a second for questions?
You have time for one quick question.
When are we going to see CTFE? This work?
Say it for everyone, Ali.
When are we going to see this work in DMD?
This particular thing is not DMD. This can go into the standard runtime. This uses the normal DMD. It does not use the new CTFE. It works currently.
All right, well, you got 5 seconds left, so make it count, or you can just applaud him, whatever you prefer.
Applause! Thanks, guys.
Thank you. Well, I want to present you a recent development of the GC in our runtime. And the most important change for me is that we finally have a precise GC in the runtime, and that means it can scan the heap precisely and detect false pointers for most types. This is implemented by passing type information to the allocation functions and others, but no type information change is available after allocation. That was in the proposed precise GC I presented 2013 on DConf, so it's finally after 6 years. There's some, because the change, that information cannot change after allocation, the special layout of arrays is implemented into the scanning inside the garbage collector. You can enable the precise garbage collector by selecting this command line option or embed runtime option into the binary by linking this string or the string array into your binary. And for the data segment, we already have since some versions this option, and but this is only available on the Windows. So in addition, we have an open GC registry where you can link your own garbage collector into your binary and then select it via the same option. This is implemented in core GC interface. The interface is defined there, and you have to implement it. You can register it with a C runtime constructor function. It must be registered before the D runtime starts, because static initializers might already allocate. But if you never allocate with the GC and you really want to forbid that, you can also redefine this register default GCs function and remove all existing GCs as well. In addition, some optimizations have happened, and my vision of a workable interactive application is if it needs 1 GB of managed memory and pauses under 50 milliseconds, then it's fine. That would be a rather good achievement. We are not yet there, but with my test that parses the parser itself 100 times and throws away every AST, that's some of kind of a representative test case, and the baseline with LDC is this benchmark result. Where it's especially interesting is the time that it's spent in the GC, that is more than a second, and the max pause time, that is the time that actually all other threads are also stopped, is 330 milliseconds. We discovered that some memory is wasted because we so far only allowed allocation sizes of a power of 2, and we added at least one value in between without changing the other allocation strategies. And so in this case, the reduced memory is not that much, but it can lead up to 20% less memory being used. And there is so far mandatory cleanup.
30 seconds.
Oh, okay, so I have to speed up a bit. These optimizations lead to some removal of sweep time and recover time. This is special phases within the garbage collection, going down to about 380 milliseconds. But after that, the big breakthrough here is having parallel marking inside the garbage collector, which brings it down to.
That's it. Time's up. Sorry. That's it. Applause, everyone. All right. Well, here we go. Your time is starting right now.
Well, I want to talk about type-state-oriented programming introduced in this paper. Well, most people know object orientation if you have like two types which are related. Example, a citizen and a superhero, and the superhero can fly but a citizen can't. Then you define your method in the superhero, and if you try to call it on the citizen, then the compiler complains. However, what if you have one type, but methods that are sometimes valid and sometimes not, for example, in a file? To know which method you can call requires knowledge of program flow, implementation perhaps of your file class, and, well, you need coffee. So, what these authors propose is statically checked states. For example, you have a file class with various states. A file can be closed, which can be opened, an open file can be read, etc. I've tried to make a small proof of concept of this in D. I have a class file, and I have inner classes that extend the file. And I use the compiler to match the state. I use open methods for this. Open methods allow you to define virtual methods outside of the class and then call the method related to the instance, to the type of the instance. For example, if I want to read a file, I use the above method. I initiate the file with a static method. I only expose the file base class, and I have to match the type to be able to use more advanced features. It works, but it's rather clumsy. You also need to pretty much adhere to a design pattern, and well, design patterns are bad, in my opinion. But it's funky stuff, and funky stuff is like the positive way of obscure, so that's good. And well, if you want to try things like this, just put it in production code and see what happens. That's my advice. If you're interested in the full implementation, it's on my GitHub, and the original paper is linked here. Well,
All right, well, you've actually got plenty of time for questions if anybody has one or two.
Can we go back to the last code?
What this code actually does, we define a virtual method handle on a file. Then with some mix-in magic, we actually call, for example, the open file handle method. It then returns a new, potentially new instance of file, which represents the state the object is in. In this case, if we have a file with extra contents, then we still get an open file back. However, if the file is at the end, then we return an empty file.
All right, still time for one quick question. No one? All right, well then let's call that done. A round of applause for Marco. Then start, you're off.
So, yeah, hi everyone, I'm Joe Wakeling, also known as WebDrake, and about 2 years ago at DConf Berlin, I made an announcement about snap packages for DMD, Dub, and LDC. So this talk is to basically update you on what's happened since then. So first thing, if you don't know what snap packages are, they're an approach to universal packages for Linux distros, so you should be able to install them anywhere, whether it's, Ubuntu, Arch, SUSE, pretty much anything you like. You can find out about them at snapcraft.io, and there are instructions for installing the snap package daemon on whatever Linux system you wish to work with. There is currently still a package for DMD, which covers multiple releases all the way since 2.076. For Dub, where we just have the latest stable version always available, and for LDC, which is, I think, every stable release since about 1.1. And what this means practically is that on any Linux distro where the snap package daemon available, it's super simple to install. In this case, I already have it installed, but for example, I can, if I want to, switch between any minor version of DMD, and it will just download it and install it. So and not only that, but it will keep me up to date with the latest version of this minor version. So if a 2.080.1 goes out or whatever, that will automatically go up. So this thing will auto-update to you. I can, for example, switch to, let's say, 2.084 if I want to, but I could also switch to just say, give me the latest stable version of this thing. Or, for example, I could say, give me the latest bleeding edge version, which is 2.086. So if anyone wants to try this out now, I would really appreciate it if you would try out this latest 2.086 version and tell me if it works. So I started putting these things out probably, more than a couple of years ago now. I didn't get a lot of feedback from people in the community, so I didn't know, but about October last year, I put up there was a little notice put up on the downloads page on dlang.org, and then something happened, and I didn't notice this until the beginning of this year, because I wasn't hearing anything, but there's now about more than 5,000 users of the DMD package, and almost 5,000 of the Dub. What's slightly worrying is that there's only about 50 users of the LDC2 package, and I think that's because LDC2 is not mentioned on the home page, so it's going to go there. The other change that has happened is a wonderful person called Ernesto Castellotti showed up on the Snapcraft forums, was also interested in doing snap packages for D language tools and projects. More about him on his homepage here. And he has got in preparation, not only is he helping me keep DMD and Dub up to date, but he's also got in preparation a whole load of other snap packages for various tools. So this is all Ernesto's work. The only reason it's not published right now and available for you is a small bit of bureaucracy that we have to go through to make this happen. And when that happens, you'll be hearing an announcement. So please give a thought to using these tools. They should be very helpful on pretty much any Linux distro. And yeah, that's it.
All right. Do you want a quick question? You got about 30 seconds. Quick question? All right, very quick. We got 30 seconds.
Just a quick one. Those active stats, is this thing phoning home to some server and telling the server who's, the number of users that are active?
So I'm not entirely, I think it's going by how many auto updates happen. So by default it auto updates. Oh, yeah, sorry. By default it auto updates, but you can turn that off if you are paranoid about who's listening to you and only update manually.
All right, well, round of applause again.
Okay.
And it looks like we got Nicholas now.
All right.
And you're also ready to go, so
Yes.
just give me the thumbs up and I'll start the timer.
How do I scroll on this? There we go. Good. All right, so as you probably know, we're having an AGM. The agenda is here. Please have a look at it. Please discuss it, because the more we discuss before, the more useful stuff we can get done. Now, so on to what I actually want to talk about, which is Repositories. dflat, which is a C# .NET wrapper that I've written over the last couple of months. It's rather alpha. What it is a C# application that reflects on a DLL and dumps a bunch of static methods so that we can call it through the core language runtime. Unfortunately, this only runs on Windows because you can't save generated DLLs for God knows what reason on a non-Windows platform. So what that allows you to do is to call, where do I test? That's not what I meant to do. Let's try that again. Is to write code that looks like this. So we declare some C# namespace stuff with the function we want to call. There's still a bunch of test code in here because I have fun on Windows trying to get stuff to work. But that's the class driver is the name of the library we want to reflect on and generate stuff from. We create the host with that. Currently, we create a wrapper for that using, it's a class at the moment, but that's going to become a struct. Anyway, we can call that, and it works. We can call C# static methods through that. The unpin there is because C# has a GC, and we have a GC, and two GCs don't play particularly nicely together. So currently the strategy is to, when you want to call a C# method, disable the DGC, call the C# method, and then re-enable the GC on the other end, so that you don't get horrible bugs. There's some notes on why this is the case here. This was mostly just me dumping brain dump of what problems you will have if you don't do stuff properly, and a note of the current strategy of how things need to work. So what this will enable is completely horrible performance of calling arbitrary C# code if you want to iterate rapidly and you have some code in C# that does what you want to do and you just want to use it and don't care about performance, because that does lock the GC every time you call it. That's about it. This is very alpha. This will change quite rapidly soon, but it does work. And yeah, any questions?
Yep, raise your hand if you got one.
No questions.
Looks like you're all good. Round of applause for Nicholas. Off you go.
Okay, so I'm Maurice Séché. I'm the lead developer of Bitcoin DBC, which is like a cryptocurrency software you don't need to really care about. I've been in the D community for a fairly long time. And today's topic, I want to make a bit of a problem statement of what I'm not using D more for what I'm doing, and then more problem, and then that's a lot of problems. So I'm a lead dev of a large application, large-ish. I mean, they are bigger than that, but it's about 200,000 lines of code. It's not exactly modern C++, but it's C++ anyway. It takes like 1 hour to compile from like a fresh compilation, so it takes forever. There are like serialization, deserialization stuff. For anyone that have done that in C++, you know that it's probably preferable to poke needles in your eyes. It has a lot of multi-threading, same thing. This is awful. So DMD would, look like a very good option for me. It's a system language, and I need that because I have cryptography. I need to avoid side channel in all the crypto code, so that means I need to control what I'm doing with the cache and the branch predictor and stuff like that. I can only do that with a system level language. And I also have low latency constraint in some part of the code, and so I need to be able to control things a bit tightly. It has very fast build time. It has a type system that helps me with trade safety. It has also, like, for deserialization and deserialization, because of introspection, you can go crazy fast. I mean, like, I implemented the whole protocol that we have in less than a day just by implementing, like, a set of function, like, you serialize, deserialize an int, and whatever we have else in the protocol, a vector. And then a bunch of struct, you reflect on them, and boom, you have the whole protocol implemented in less than a day. So that seems like a great stuff, right? But I've only been able to use D for like prototyping, simulation, doing various measurements, stuff like that, but not in the core application. And this is because I have challenges. And they pretty much all fall in the same category, and that category is like weird shit, right? There is weird shit happening all the time with D. So it's not like missing features and stuff like that. Like people are talking a lot about new features that they need, and I have everything I need in D, right? But most of those features, they're like 95% there, and then the remaining 5%, this is the Twilight Zone, like stuff appear in there, disappear, like I don't know, nobody understand any of it, you know, like immutable enums and stuff like that. So we started calling that weird shit because this is very weird. And I want to go through a few examples. So we have compile time feature, they are great, right? But we have like language construct like static if. We have a stud trait that does like half of the thing that you need to do and not the other half. And then you have like a bunch of very bizarre compiler thread that like none of them works consistently. And what is that, right? Like it's very complicated. Nobody has any idea what, like, you know, we just like copy paste recipes that we have just like the C++ guy do with templates and you know, like they unwrap this 25 different series of templates to do whatever they need to do. Okay, so we have type qualifier, they are great, but we have shared. Apparently, the only thing it does is prevent you to increment using ++, but you can still do +=1, so you cannot construct any of them safely because you need to construct them thread local and then case them to shared. This is what the spec actually tells you to do, but this is also the spec that tells you this is undefined behavior. And so as a result, it doesn't provide very much guarantee in the type system. So what is that? They support profiling and code coverage out of the box. That is awesome. This is the kind of stuff I need, right? But all the file format that it dumps out of it, they are not like standard file format that is supported by other toolchain. I can use none of the tools that exist like gprof and you know, like whatever is my IDE and stuff like that. So what? The unit test, D has a unit test block, and this is, honestly, this is the best unit test feature I've seen in any language, especially because of the way it pairs with the way visibility works, like public and protected and private and all of that. It allows me to test a bunch of stuff, and in other language, I have to build weird scaffoldings to be able to test what I want to test. And this is like, honestly, this is like the best feature ever, right?
30
but
seconds.
The test run before main. Like, what is that? Right? I don't want to run the test and then my application at the same time. There should be like two parts of the build that are different. Okay, we have like optional Node.js. Maybe I have 30 seconds, so I'm gonna go fast. It's like, there are some weird stuff in there as well. Okay, so I really, really want to use D. Like, you guys need to save me from C++. This is horrible. There is like even more weird shit in C++, but I don't need new feature. I need like
and
this
that's it, you're done. Thank you, Amaury. Ready, set, off you go.
Okay. Now, this here is a mobile phone. And let me just log into it. So, yep, this is an ARM64. How many processors have we got? 8. And 3 gig memory, 1 gig swap. Yeah, we have a compiler here. GC21. And yeah, that tells us pretty much information that we're looking for. So AR64. Let's run the test suite. After a while. And we're passing. Now, I'll stop this in a minute before my phone dies, our battery. But yeah, pretty much, so this will actually pass all to completion, 100% passes, no problem there. Pretty good, although very little that I actually did in order to actually achieve that. It was sort of very much, small bits and pieces here and there. Excellent, you're on the wrong screen as well. How do I move you? I can't move you. Let's do you this way. So, yeah, there's really small things that will really sort of very niggly things in the D runtime to really sort of get this sort of stuff working. And as I was porting various architectures, this sort of stacked up, and it's just a couple of lines here, a couple of lines there. Really just sort of show you sort of a few examples, sort of question and answer session. So what do you think is the problem with this function? Yep, Stefan?
The stack grows in the wrong direction.
Yes, on when the stack grows up, pthread get stack is already at the bottom, so there's no need to adjust it. So we add version stack grows down, adjust. Next, why would this assert fail?
Endianness.
Endianness, yes. On little endian, HELO is on the left-hand side. On big endian, it's on the other side. Next, why would this throw a sig bus? Alignment, indeed, because, well, on 32-bit platforms, well, mutex is a class, so that alignment is wrong, and the pthread may require an alignment of 8. So you might get lucky and the first array is on the correct position, but the second is not. So, again, fix would just be to have two separate global with the correct class instant alignment. Next, why would this seg fault? The external API accepts a void. The internal is actually a struct. So while on x86, void pointer and struct with a pointer are passed in the same way, on some architectures, they're passed differently. Next, why does this have silent corruption? Yep. No. So the for each body is turned into a delegate. Remember, for each int I. This calls this function, which uses size t, and passes the size t as a pointer. Now on little endian, all the bits are on the correct-hand side when it gets truncated. On big endian, it's on the opposite side, and so the index here is always 0. The compiler should warn about this, and it does for
30
static
seconds.
arrays. And finally, why would this seg fault? Strict alignment. That's kind of a workaround, but you kind of get the idea of what's going on. Now, currently in GDC, these are the targets that we support. This is what I want to extend to in the next point release, and these are various, when they came out, these are the compilers that I...
And that's time. Thank you, Ian. All right, then we're starting.
I'll show, got a few questions about Nix, so I'll show you how I use Nix. And the first thing I'll show is how to add Nix packages to your local path. So nixenv-i installs a package, but only to the local user in the path. So I'll use dir-env. Anybody familiar with dir-env? Yeah. So dir-env is awesome, especially with Nix. So you can say, well, I'll show you first. I have nothing up my sleeve here, right? So I'll say I want to use Nix. I want to have dmd, dub, and dub to Nix. I create a file rc. Now dir-env is complaining that the file changed, so I allow for this folder. Oh, that is a good one. I'll remove this guy. So dir-env, as soon as you go into the folder, the env-rc file is interpreted, and now I have dmd and dub in this folder. If I go out, I don't have them anymore. That's good. Let's create a 5D project. Everything default sounds about right. So now I can build this. Okay, that works, but now I want to create a Nix file for that. I'll show you later why. I'll do dub to Nix save. It prefetches all the things from the selections file. prefetching because it needs the SHA-256 for every package. It's not happy with just the version number. So it prefetches a lot of stuff. Okay, there we go. So now what we have, this was a failed, we have a dub-selections.nix, and we can actually use that thing. Let me also, actually, I should have done this. Okay, it fetches again. It's not enough to just have the dependencies. I also want to have the skeleton for the actual application. So with the -o, it creates a Nix file for the actual application. The Nix file is fairly standard. It just imports the local folder. I make a dub derivation for the folder I'm in, and I can build that. So I do build default Nix. Aha, so now we're getting somewhere. It fails, and why does it fail? Because the build process for OpenSSL for 5D TLS tries to write in the Nix store, and that is not possible, right? Everything is immutable. You're not allowed to change stuff inside that store. And why is that? When you want to use 5D TLS, it tries to find out what version of OpenSSL you have. And then during the build process, it does an OpenSSL-v and creates a D file with that version in it. But we cannot create anything because that's not deterministic. So we'll tell it to stick to one particular version by using a subconfiguration. Forgive me if I don't align everything. Why am I doing this in Vim? I don't know. Okay, so we try it again. Nix build. And what Nix build does, it tries to build and then creates a result inside the local folder. Let's see if this works now. This is not the most exciting lightning talk like this. Anything else? Well, I can switch to another thing while that is building. Not sure. Oh, time seems to go way slower when I'm up here. Okay, so it fails.
30 seconds.
That's what I thought. It's failing because we're missing one dependency, and so we tell Nix that we want OpenSSL, but OpenSSL comes from another thing, and that is from the official store. So we need this. And this would result in a proper build, but it takes too long. So what I show, you can add any native dependencies.
That's time. Thank you, Leo. All right, we got to. Your time starts now.
Okay, so first of all, I'm here to talk in the name of the group, D-Lang group from University Polytechnic of Bucharest. So we've been attending DConf for about 3 years, and absolutely every single year we heard talks about how to raise the popularity of D. Usually when we talk about this, we have two perspectives. The one is that what features do we need to add, what features do we need to improve so that we raise the popularity. Well, we agree with Omori. We already have a lot of features that are working okay, so if it's popularity that we're interested, that's not the right perspective. The other one is marketing. We always talk that we need more marketing, Rust has marketing, and look, everybody knows about Rust and so on and so forth, but we don't have the money. Okay, so we don't have the money, we've hit a brick wall. Now, I'm here to present a different perspective, a perspective that we all adopt in Bucharest. Now, since we are all educators over there, teaching assistants or professors, we kind of have this motto that get them while they're young. So, yeah. I know that didn't sound right, but... So, the thing here is that we want to try like this reverse strategy, and if we let people know when they're young about this cool language that we like, maybe they will remember, and when they get hired and they're in the situation that Attila was. Now that they have DPP, they can push D. And I know that it's kind of a long shot, but what other alternative we've got? So in order to support this, we've been constantly trying to push D to students. So yeah, that doesn't sound really well also. So we've had some projects. Alex also is doing his bachelor thesis on this. And anyway, what I was trying to do is to announce that this year we're holding a D summer school at our university. We want to take like 40 students and show them the wonders of D. And I think that if you guys, wherever you work, and try to support D for the young people, then maybe that's a strategy that will pay off in a few years. Thank you.
And go.
Thank you. You'll have to imagine the best slideshow you've seen today. I'm James. I've spent a lot of time over the last 6 years working with D on a number of satellite data processing projects. There is a very interesting kind of satellite data that allows you to track the movement of ships on the oceans. It turns out global shipping is basically a massive IoT network. Ships talk to each other using a machine-to-machine VHF radio communication system, which they yell, "This is who I am, this is where I'm going, this is what I'm up to, this is what kind of cargo I'm carrying," to help captains avoid bumping into other ships. It's a safety of life system. And it was discovered quite recently that the signals can be picked up by a low Earth orbit satellite. So various companies have been filling the sky with constellations, and nowadays you could, if you pay the right people the right amount of money, you can get lovely real-time feeds of kind of order of 50 million messages a day broadcast from all over the globe. And we've moved in a fairly small number of years from a situation where we had no idea what happened on the sea to a really very strong idea. The problem is that the engineering, the work to translate this data into useful knowledge is quite challenging. And as the field is so young, it's often rather badly done. So my users, my clients, have been primarily in two groups: scientists who want to understand questions like where does the fishing in Europe take place, because it matters, for example, for governments who want to plan things. Or the second group is forensic analysts who are interested in crimes that take place on the sea and want much more interactive tools. But both groups want they both want to do data science, but some of them also want tools with much better latencies. The traditional way you do this is by throwing it at Hadoop. Turns out writing Spark jobs for this kind of data is very hard to do. A lot of money gets wasted. A lot of money gets wasted on teams that produce systems which produce the right result, but run for kind of weeks and weeks doing not very much. So after a certain amount of time helping people do this, you go, a much better approach is to attack it with efficiency rather than parallelism. The data rate, the data volume, it's kind of in the tens of terabytes range in uncompressed JSON. So it's in that netherworld but it isn't quite big data, but it's too big for standard tools. So you ask yourself, if we want the productivity of Python and we want the performance of C++, is there a language that can help us? D turns out to be an absolutely perfect fit. It's a kind of bizarrely perfect fit, actually, because everything from command line batch processing to where you just want to do a job as a one-off thing, to building infrastructure that can serve up a reasonable number of queries with very, very good performance, D slots in perfectly. The most interesting work, the work that really stands out as a result of the project, is that if you want to build, this is a time series problem. You get all these messages, you project them into a series of representations, each of which captures one essence of the kinds of questions that your users want to ask. So, they might be interested in the way ships move, because that tells you something about the way they do. You basically do ML on that. They might be interested in where they go, because you can build up patterns of which companies are touching other companies. And you do this by projecting the data into highly optimized, essentially special purpose databases, which you write with very specific data models and chunking and ordering and invariants and particular indexes you write. and you memory map all of that. You say take over a 2 terabyte SSD, that kind of thing, and you memory map all of that and get out ranges of spans of memory map data, which you then put to long chains of range processing, which is what D is wonderful for, and it works beautifully well. It's sort of embarrassing, actually, the amount of correct code, the amount of correct behavior you can get from a very, very small amount of really very beautiful code, most of which has come from the standard library anyway, and you've just added a few more generic algorithms. Your storage engines kind of...
Sorry, 25 seconds, by the way.
Thank you. Anyway, so you use the metaprogramming design the storing engine to make that cheap. So as users come to you with different kinds of queries they want to be able to run fast, you can materialize the databases they need to do that quickly. Then you run generic algorithms over them, but you get to reuse the algorithms because it's D.
Well, that was a certainly impressive compression of your talk there. Congratulations. Thank you. All right. Yeah, I'll take that. Okay, and that was the last of the lightning talks, which consequently means the last of today's talks and the end of the second day of DConf. So please give all the talkers again today a round of applause.